Hi, folks. We'll get started in just a couple minutes. Give people a little bit of time to drop in. As we get settled in here, please feel free to use the chat to let us know where you're calling in from today. We'll wish you a time zone appropriate greeting. Good evening, good afternoon, or good morning, depending on what continent and side of the continent you're on. We've got a great agenda for you today. Folks from a few different organizations. Aha, from Colorado, but calling in from Ireland. That sounds like fun. If you're just joining, we'll get started in just another minute or so. Just letting everyone say hello and where they're calling in from in the chat. We'll use the chat during this webinar as we go along here, but we'll also use the questions feature. That'll be a great place to drop questions and you can go upvote them. And at the end of our conversation, our presentations here today, we'll answer what we can get to, and we will definitely follow up on the rest of those too. We're going to give folks just one more minute, and then we'll jump on in. Literally in your backyard, Aaron. I love it. Nice day in the Bay Area. The conveniences of California. All right, we've got a good group together here. I think we will go ahead and jump in. By way of introduction, my name is Ryan Sholin. I'm the advocacy lead here at Electricity Maps. And we've got a good group for you here today. We're gonna go for about 50 minutes. As I mentioned, let's use the Q&A feature here so that you can ask your questions and we will get to them at the end. You are more than welcome to go look at the questions tab and upvote your favorites so that we know where to focus, where to prioritize. We'll have a couple of polls. You won't miss them. And of course, at the end of this, and as we follow up, we will send you the recording of the call so you don't have to vigorously take notes if you choose not to. And we will make sure that everybody gets their questions answered in the follow-up as well. Joining us today, we have Pierre Segon, lead engineer here at Electricity Maps, Varun Mehra, a technical program manager from the team at Google, and Dan Benita, principal contributor for the Carbon Aware SDK at the Green Software Foundation. So for our agenda for this call, we're going to talk about growing your IT carbon footprint and how grid signals can help with IT sustainability. We'll also get into the future of the sustainable cloud and data centers. Obviously, data centers are a very hot topic right now, especially around AI and energy demand. And then Dan is going to talk about collaboration and how you can work with some of your like-minded organizations and industry partners to build sustainable IT solutions. Then we'll finish up with a little more Q&A and talk about those questions and answers. With that, I'm going to hand it off to Pierre.
Great. Thanks a lot, Ryan, for the intro. Yeah, it's a pleasure to see so many people connected and who are interested in hearing about the practical implementations of carbon awareness. It feels like time has passed since the first time we tried with some of the other engineers at Electricity Maps to implement that within Electricity Maps, which at the time felt like a completely crazy thing to do. So it's great to see. Um, so the reason we're having this webinar today is that we now live in a world where the carbon footprint of electricity varies in real time. It wasn't the case before when there wasn't so much renewables on the grid. So we need to learn to adapt to this new reality and capture the opportunities it offers to clean up the grids. And that's particularly relevant for the tech industry, as we're going to see. So here we can see on these charts the hourly makeup of the electricity mix in California over 3 different days, and the related carbon intensities, that is like how clean the electricity on the grid is. And you can see that every day the solar ramps up, the solar production ramps up, and that is matched by the carbon intensity of the grid going down. So that shows like how much the cleanness of the electricity can vary from 1 hour to the next. You can go to the next slide, and we can see that in other places we see similar patterns, but that are caused by different power production sources. Like where I'm at right now in Denmark, we can see that when the wind is blowing, there's a lot of wind production, and that also correlates with low carbon intensity. So you can go to the next. Yeah, so at the same time that a significant amount of renewables are being added on the grid, we're seeing that the electricity consumption for key industries, such as the ICT sector, are growing quite massively. This is not about to stop anytime soon, as most prediction, including this one from the IEA, that is the International Energy Agency, are showing. So this foresees that the total electricity consumed by data centers worldwide will increase by a factor 3 within the next 10 years. And that should be matched by a similar increase in total emissions. As in the base case scenario, it's foreseen that all of that extra electricity that is going to be consumed will not come from exclusively from carbon-free electricity sources. And so that could result in a situation where data centers every year emit around 340 megatons of CO2. And for reference, that's about the same as the whole of the UK emitted last year. So we're talking about emissions that are significant at the global scale. But luckily for the tech sector, its growth does not need to translate one-to-one with a growth in its emissions. So many resources that are used in data centers are flexible, and that's why the IEA estimates that worldwide, data centers could provide up to 50 gigawatts of flexible capacity by 2035. And that would represent about a third of the projected average power consumption by then, as was predicted on the previous slide. So that presents a massive opportunity which motivated us to host this webinar and to talk about carbon awareness. Wait, can you go back? I'm not. Yes, thank you. So on one side, the amount of intermittent renewable generation is increasing at unprecedented rates, resulting in large variations of the carbon footprint of the electricity. For example, we know that solar has been the source of new added electricity that has been the largest in the last 3 years in a row. And on the other side, we know that the tech industry as a whole is growing rapidly, consuming ever-increasing amounts of electricity, and it has an inherent capacity to consume electricity in a flexible way. And we can therefore discuss carbon awareness and see how we can tap into that potential. So we can move on to the poll. Yeah.
Sure. Thank you, Pierre. So as we get started here, we want to ask you if you're currently measuring emissions. If you're not, or if you don't know, we would love you to drop in the chat, what you would like to be measuring, or if there's a reason you're not measuring. We're, of course, very curious. It's about 40-40 right now. 40% and 40%, with the rest being I don't know. But more no's than yeses, which means you're in the right place to learn about how to get started. I think just about everyone has answered, so we will move on to the next part of our conversation, where I'll ask Pierre to continue and talk about different reasons to measure and how you can measure.
Thanks, Ryan. Yeah, so before diving into the topic of carbon awareness and how you can optimize for carbon reductions, I wanted to quickly touch on the topic of emissions reporting. And it seems like it's also relevant, as there is a majority of people that are not currently even reporting these emissions. And yeah, ultimately that's because the potential for reducing reported emissions in the case of tech will be constrained by the carbon accounting methodology that your organization uses. And yeah, so and the tracking the origin of the electricity is actually a surprisingly difficult topic. The thing is that we cannot paint electrons when they come out of a solar panel, for example, with a particular color and observe, well, then they'll end up on the grid and assign their consumption to a particular customer. So that's why there exists some methodologies to help map the origin of electricity and assign emissions for that consumed electricity. These methods are generally split in 3 different broad families. So in the location-based method, consumers cannot really choose what they consume from the grid. And so, for example, 2 adjacent houses would receive the same electricity. In a market-based model, the consumers are able to buy certificates to claim the origin of the electricity that they have consumed, and they can cover, for example, their whole yearly emissions thanks to that. So in the case of 2 different houses, one could claim that they only consume electricity from wind and the other from solar, for example. And on top of that comes something that is referred to as granular accounting or 24/7, which is a method that builds on the system of claims from market-based, but adds some time and location constraints. And if this is all new to you, I'd recommend watching the recording of our previous webinar where we discussed these things in more depth, so you can better understand how these reporting standards work and how they can apply to your organization. And I think we'll provide a link to that towards the end. And so to go back to carbon awareness and to understand why this context is important, let's imagine that you were working for a company that only uses this yearly market-based view and report that they're using 100% carbon-free electricity. If you were to implement some sort of optimization procedure to execute some workflows when the electricity is green, well, the problem is you would not see the effect of this on the reported emissions at the organization level, because the emissions are already at 0. So I would advise anyone wanting to implement carbon awareness to make sure first that it fits with your organization's reporting standards. Let's move on. Yeah, so I've been talking quite a lot about carbon awareness, but I just wanted to remind the audience of what I mean by this. So with computing, in the default case, what happens is we want to execute some sort of task, and the way we're going to decide on when to execute that task can be quite random. It can be done on like a fixed schedule, or done when someone just clicks on a button to execute something. And by doing this, we are not guaranteed that this execution is going to match when the electricity is on the grid, and end up in cases where the electricity that powers that task is actually quite dirty. But with carbon awareness, that's the next slide. Yeah, what happens is we delegate the choosing of the time of the execution of that task to some sort of scheduler, which has access to an optimization signal And it will be able to specifically target the times when the electricity is grid to execute that task. That's what we mean by carbon awareness. And it can also be applied spatially, so choosing the spaces that have access to clean electricity. But my following points will be agnostic of this difference between time and location. So I just wanted to mention that. So this concept is very intuitive. It seems like, yeah, if we're executing my task when the electricity is grid, it's going to reduce overall emissions, right? Well, the reality is a bit more complex than that. And it's difficult to verify that shifting the execution of your job results in lower global emissions. And I want to use an analogy to give you a sense of why. So imagine that you're looking at a highway where there's quite a lot of traffic, but you still see that the flow of the vehicles is quite fluid on the highway. Then you also see some vehicles that are about to enter the highway. Would you be able to know in advance whether adding, for example, a motorcycle would change the state of the flow of the vehicles and cause like an accordion effect or even a traffic jam? What if it wasn't a motorcycle, but a car that was coming on the highway, or two cars, or even a bus? What we're looking at is like a complex nonlinear system. So it's very difficult to predict how the states of the flow of the vehicle would react to any perturbation. And that's exactly, it's quite similar to what happened with the electricity grid, as trying to illustrate with the next slide. Yeah, so for the electricity grid, we want to know whether changing the consumption with one task would result in a different configuration of the grid, which would mean different total grid emissions. So in our analogy, the change of power consumption you're inducing is analogous to introducing a new car on the highway, for example. That new consumption has the potential to change the state of the nonlinear system, which is the grid, and that can, down the line, result in a power plant that has to fire up and result in different total grid emissions. Can you go to the next slide? Yeah, and so the problem is that understanding how the grid reacts at when a new load is added or when a load disappears can be very difficult. As for the traffic flow, it's like a complex and nonlinear system. And we've been talking with grid operators and research institutes, which confirm this intuition. It's near impossible to predict how the grid would react to a change in consumption. And that means that any optimization signal that tries to predict the reaction of the grid for carbon awareness is unfit for its purpose. It would most likely oversimplify reality and pose serious verifiability concerns. So that's a problem. If someone tells you, yeah, I can predict how the grid is going to react to you changing this and reduce your overall emissions, that poses concerns about the credibility of these claims. So can we move on to the next one? Yeah, so that potentially poses some problem for carbon awareness, right? Well, the thing is, there are some cases when we actually can say how the grid is going to react. For example, if your grandma is boiling some water to prepare some tea, you can imagine that the grid operators are not going to react to that single event. Otherwise, they would be overloaded with all sorts of these events. And that's because the amount of power required for that kettle to heat up is just a drop in the ocean from the grid perspective. The power required is not so much, and therefore the grid is not actually going to react by turning on a new power plant to answer that new demand. And just for reference, the power of a kettle, that's like roughly 1,000 watts, is the same order of magnitude as a very beefy gaming PC, for example, or a few GPUs. So for this reason, I like to distinguish between two different cases when discussing the practical implementations of carbon awareness. The first, which here I call the mosquito, is when we are shifting jobs which consume small amounts of electricity at the scale of the grid. But that can be important jobs like shifting the usage of a cluster with up to 50 virtual machines, for example. In this case, well, the implementation of carbon awareness is straightforward because you know you're not really going to change anything on the grid. You can choose directly the best optimization signal for your use case and optimize for your own reported emissions. But when the amount of electricity being shifted is much larger, in the order, for example, of the megawatt and over, which can be reached when we're talking about shifting a whole data center, for example, we have to be a bit more careful. And the reaction of the grid, as I explained before, is going to be difficult to predict, which can lead to unforeseen consequences. And that's why, in this case, carbon awareness should be extended to what some people have called grid awareness, where optimization can also take into account grid dynamics. And that can help avoid shifting at times where the grid is under stress, or on the contrary, try to target the times where carbon-free electricity is in excess. Yeah, so at the scale of the mosquito, the carbon awareness can be a powerful tool to reduce your organization's footprint. And I want to give an example that we've seen at Electricity Maps. We've been playing internally with carbon aware schedulers, and we've seen that they have enabled us to reduce the carbon footprint of some services by around 30% when using a location-based or granular accounting assessment. But remember, again, the caveat here is that the reduction that you're going to see yourself don't necessarily translate to real-world emission reductions. They will most likely come at the expense of everybody else's reported emission, but it's going to be so insignificant for everybody else that no one will notice it. And therefore, when you want to implement this, you should take into account what is really the objective that you want to pursue. And there are different signals that can enable different optimization strategies. If your use case is to reduce reported location-based emissions as much as possible, for example, then using forecasted flow traced carbon intensity would be the best suited, as later down the line, that's what's going to be used to account for emissions. If in your use case you want to target times with high level of renewable generation, then using a forecast of the renewable share of electricity or of the net load, which is the total demand minus the solar and wind production, would be best suited. And we've crafted a guide at Electricity Maps that highlights what signals are the best suited for the most common sustainable IT use cases. And I think a link should appear now where you can access that guide. If not, we'll share the slides. Yeah, and so even though up to now I've painted a pretty pessimistic picture of the real world impact of shifting these mosquito jobs, there's also a great opportunity with those. If we were to shift the charging of all phones in the UK, for example, assuming there's like 50 million phones and each charger consumes 10 watts, we would have the capacity to shift the consumption of up to 500 megawatts, which is the same as the power output of like a nuclear reactor, for example. For computing jobs of 100 watt, we would only need 10,000 of them to reach 1 megawatt, which is kind of the line where we have the potential to change the status of the grid. And so that means that if all these mosquito jobs are coordinated and using the right grid signal, they have the potential to lead to real-world reduction in grid emissions. And if that shifting is done in a predictable manner, it can also help stabilize the grid and provide the right long-term incentives for decarbonization. And yeah, that speaks to this idea of triangle of action that we've communicated about in the past, where if you have many organizations and individuals that start implementing some carbon-aware practices, it can send a strong signal to both institutions, but also large tech corporations to integrate this better. And the good news is that if we are able to, so can you go to the next one? If we're able to go to a state where all of these small carbon-aware jobs are significant, we already have the tools to make some of the large jobs and shift in consumption happen without disrupting the grids. And I think Varun from Google will give more flavor to this in just a second. And finally, I wanted to mention that optimization is great, but that's not the only lever we have for action. And that if you want your organization to reduce its overall carbon footprint, there's other things that one can look at, like reducing the total amount of energy used, or making sure that all the services are running in places with easy access to carbon-free electricity, or using providers that are powered by additional carbon-free electricity. And I'll now, give the floor to Rowan. Thanks.
Thanks, Pierre. That's a perfect segue. Let me start really on the reduction upper right box you just had on the previous slide, if you go to the next slide. So I've been at Google for a few years, but there has been a decades-long investment in data center energy efficiency in the form of what Google calls, and I think the industry now calls, PUE, so power usage effectiveness. So the upper right diagram just gives you an indication of if a data center is drawing from the grid, how do you delineate the fraction that's going to the IT load? And then from there, you can then measure what the data center drew versus the ratio to the IT load. And that's your measurement of power usage effectiveness. And so it's really about the overhead, the balance of data center measurement. So cooling, mechanical, fans, losses, et cetera. And Google has been year over year continually trying to optimize and improve that ratio. And I believe in an industry leading way. So 1.1-ish on average across the global fleet of data centers that Google operates, I think is pretty impressive. But obviously we're here to talk about carbon aware computing. So if you go to the next slide, IT load is a huge driver, is the driver of energy consumption at a data center. So even if you optimize completely for your PUE, you're still left with all the machines and the workloads that are running on those machines. So that led in 2020 for a bunch of smart people at Google to think about what can we do to optimize IT load from a scope 2 perspective. And so that led to the first launch of carbon aware computing. And so this was really focused on temporal shaping load at every data center where possible by aligning shiftable workloads with carbon intensity. And again, as mentioned, Google does serve billions of users with numerous services. And the focus of this effort was identifying flexible workloads in the B2C. So it's kind of on the consumer side versus the B2B. And certain tasks can be kind of batch processed or throughput oriented with some latency tolerance. And those tasks are the ones that are targeted for carbon aware computing. So some examples we've given in the blog here, bulk uploading and processing of videos and potentially photos and things like that. I think we even wrote an academic paper on how do we model and actually do this. We had Google built new infrastructure to do this. So it requires forecasting of the shiftable workloads, forecasting overall workloads, understanding the compute to power relationship based on the diversity of machines at a data center, which is kind of stepwise linear, but not strictly linear. And then, of course, the electricity maps kind of day ahead signal in terms of average carbon intensity. So ideally, from this graphic, what you're seeing is without temporal shifting and a carbon aware, and then with it, you want the workloads to be running inversely proportional to carbon intensity. And the mechanism by which that is done is, again, referenced in the academic paper. It's called virtual capacity curves. So we send limitations to all the clusters in every data center, so that the workloads do run in that inversely proportional way to the extent possible. So more kind of smaller shifts across the global fleet operating daily, and then the follow-up of that, again, if you go to the next slide, was we've got a global fleet of data centers, and if and where there's slack capacity and in green or less green regions, could you take advantage of spatial shifting? So try to guide workloads to, again, to the extent possible, to run potentially in cleaner regions and also take into account time of day. So that's kind of what this graphic here is showing, is that it's now, to the extent possible, coordinated temporal and spatial shifting with kind of the carbon signal in mind. So, of course, data centers are large consumers on the grid. And what we've done most recently with this infrastructure is leveraged it to do demand response. So demand response is different than kind of the daily load shifting. It's event-based and site-specific. So we've leveraged that carbon-aware computing global infrastructure to deliver site-specific power reductions. So again, instead of the daily modulations, can the curve be more surgical to the extent possible during times of need with the grid, as that graphic is showing an example. And that was really exciting because we've done a number of pilots that we've announced in coordination with local grid partners, where trying to help relieve stress on the grid during peak periods. So it's not necessarily purely a carbon optimization, it's more of a grid coordination during times of need. But leveraging that infrastructure. But going back to carbon-aware computing, I think where we are right now is asking some kind of not growing pains, just growing up questions, I guess. So key scaling questions when it comes to this infrastructure. The first one is measurement and verification. As kind of I described with PUE, that's a pretty well understood thing to measure and with bounds well drawn. But when you're talking about a dynamic system operating globally in scale, how do you baseline and measure impact? And kind of the second question there, part of the reason why it's complicated is as time goes on, there's changes in IT hardware within the data center, which have different power to compute profiles. There's, of course, different operating conditions that change for the utilizations of machines. And of course, the workloads themselves and the stratification and the type of workload requirements changes over time. So it makes it challenging. And then on the right-hand side, the second question, which we're much earlier in asking, but I think Pierre alluded to a bit of it, is like, what is the optimal signal to be optimizing around? You know, there's obviously a number of one, but which is the one that maximizes the carbon impact? And specifically, I think that second question is super important, is depending on the time horizons you're looking at. So the day ahead, which is what we're doing right now, versus kind of the longer term deployment time horizon. And then also the associated grid condition you're looking at, what is the right signal to be optimizing around? We can go to the next slide. I just wanted to highlight, again, everything I just shared was kind of on the B2C front, but I think in Pierre's last slide, you talked about also situational awareness for your existing carbon footprint. So on the B2B side, for folks that have IT infrastructure on Google Cloud, there is this carbon footprint feature that's been launched for a few years to give, in a B2B way, companies a picture into their scope 3, which is Google Cloud scope 2, which is a pretty interesting, not just feature because of the visualizations, but a series of attributional and methodologies to come up with a reasonably accurate way from a virtual machine to a workload to a user from a carbon perspective. Let me hand it off to who's next, or to the poll.
Sure. Thank you, Varun, so much. I'll actually jump in here for a second and ask our poll question. With what you've seen here so far today, we just want to ask, do you see potential in carbon-aware computing for your company? I feel like that's an easy yes for a lot of people, but if the answer is still no, we would love to know why. Please feel free to jump in the chat and let us know what you think. And then also, of course, if you have specific questions for any of our speakers or just in general, please do use the questions tab and drop them in. We've got some good ones brewing there so far. I'll give folks just a minute to vote in our poll. Yes is leading handily. And we have some I don't knows yet, which is good to see that people are thinking about it and trying to figure out what's right for their organization. As those votes roll in, I would like to keep our webinar rolling, and I will hand it off to Dan Benita from the Green Software Foundation to talk about collaboration.
Thank you very much, Ryan, for this. So that's a very positive stats on the carbon-aware computing, and I think it's good. I think it's, depending on whether you've already started or whether you think you can basically do it. You won't necessarily be able to make a big impact on your own. You'll need collaboration, and I think that's what we're going to try and cover in the next few slides. So if you go to the next slide, please. So real collaboration means more than just agreeing on goals. It's about making sure that different perspectives are actually working together to solve the same problems. So first, let's think at let's start with cross-functional teams, where we bring together engineers, product managers, sustainability leads, and potentially finance even, and everyone plays a role. Second, we need to look beyond our own walls. By joining industry alliances or contributing to open source communities, we can learn faster, avoid duplication, and scale impact. Third, we've got policy that matters. So, working with governments and NGOs helps shape incentives and create the standards we all need to follow, such as, obviously the having, working with a common unit. And finally, none of this works without education. So building internal training programs and encouraging ongoing learning is what makes sustainability stick. Could I get to the next slide, please? So let's talk about why collaboration is more than a buzzword. It's the backbone of sustainable tech. So shared standards like the software carbon intensity spec and tools like the carbon-aware SDK gives us a common language and a shared direction. For anyone new to it, the carbon-aware SDK is like Google Maps for workloads. It points it at your job, and it tells you the greenest route, time and place, based on live grid signals. And it's not just about having the same goals. It's about making real decisions based on fine-grained grid signals and not daily averages. I think we maybe touched on that a bit earlier, and we'll touch on it again a bit later. And open source and open data principles are what makes this innovation principle possible at scale. Could I get the next slide? So, sustainability can't be an afterthought. It's got to be built in from the start. Whether it's designing with fewer materials, coding with different efficiency in mind, or choosing where and when you run your workload, every step counts. By the way, carbon awareness isn't the only lever. Both Pierre and Varun mentioned it in different ways. But if you check the chart on the right, you've got already a few other principles shown here in what we've defined at the Green Software Foundation. But if you look on the right, it's the energy proportionality curve, that chart. And the harder you drive your hardware, the better it gets at turning electrons into useful work. So, I think here we can see that trimming just 10% of energy impacts our utilization by 50%. So in other words, it's best if you keep your servers as busy as possible. Otherwise, it's like idling a Ferrari in a traffic jam. So making the most of your hardware. And even at the end of life stage, there's an opportunity to reduce impact through smart recycling and data sanitized reuse. Yes, thank you. Can we get to the next slide, please? So effective collaboration means putting the right people in the room and keeping them talking. Think cross-functional squads that blend technical, product, and sustainability expertise. A quick shameless plug here is that the Green Software Foundation has a training portal, and it's completely free and perfect for leveling up teams before a big initiative kicks off. So making sure everybody speaks the same language and is on the same pace. Simple habits like having an sci.md file in your repo where you would be documenting your team's carbon score and logging the idea of what you plan on doing next as an improvement can drive accountability and learning. So green software needs a culture of curiosity and shared progress. Next slide, please, Ryan. So AI. AI is powerful, but it's also power hungry. As models grow, so does their carbon footprint. And that's why we urgently need standards like the SEI for AI, which is clear, consistent metrics that account for how and when workloads run. So the GSF is running workshops at the moment with different organizations to help us define this and help everybody. And the green carbon intensity can vary sevenfold in a single day. So energy-aware scheduling isn't just smart, it's essential. Could we get to the next slide? Thank you. Now, remember, perfection is the enemy of done. Start small. Nobody launches SpaceX on their first Git commit. The good news is that you don't need a massive overhaul to make a difference. One team improved their CI pipeline by adding warnings when SCI scores dropped so that they could basically monitor if what they were doing was going to make it worse. Another shifted nightly logs analysis by lowering to a low carbon hours, and they cut their emissions by 30%. And a third reduced inference energy by 40% by using precision tuning. So start small, assign each team one green pattern per sprint and review progress in green retros. It's a habit that leads to impact. Back to you, Ryan.
Sure. Thanks so much, Dan. Thanks to all of our presenters today, Dan, Varun, and Pierre. This was a lot of information. We've got a few minutes to get to some of your questions, so I'm going to go look over at those now. I see a couple that I think we might have touched on, so I want to ask one tricky one from Tim Sweetman. To what extent do data centers vary electrical load according to instantaneous demand for compute? Varun, I think you might be best placed to answer that in a general way, if not specifically for Google, but just the idea of, does demand instantly allow a data center to shift loads in any way?
I think the analogy I have is coming from energy technologies that, at least from the Google perspective, and probably most any hyperscaler, anyone operating a fleet of data centers in a coordinated way, compute supply has to exceed demand across all timescales. So from a power perspective, that requires planning, and then obviously this question is on the operational time horizon. So I think there's been some discussion about, with training, does the level of energy consumption vary slightly more than standard compute? But I think either way, data centers are designed and provisioned in a way to accommodate for kind of deltas in demand, especially when you're thinking about the B2B world, where you want to ensure that there's sufficient virtual machines and enough capacity for any consumer, large or small, to meet to run the workloads that they need to run.
Makes sense to me. Following along on that, Reza's question about kind of downstream emissions. I don't know if this is something that Google measures yet or estimates for sort of scope 3 purposes, but when we think about users, viewing billions of videos on YouTube and using lots of devices, is that something that you measure or that you think about on your team, or does that fall into other categories?
On scope 3, I think First, you'll see Google reporting all its scopes in terms of emissions in its annual environmental report. In terms of amortizing it in the B2C world to the consumer, and then attributing that and then exposing that. I'm not aware of that's kind of a high value feature on kind of the product team's roadmap. But I think maybe somewhat relatedly, I think Google put out, including some folks on our team, the life cycle analysis for TPUs, showing that with more power dense hardware, the scope 2 ends up dominating the life cycle emissions. So that certainly is and will continue to be a growing focus. It's not to say that in the embodied carbon scope 3 isn't, but just to put it in perspective.
I can add, and Dan, jump in here if you'd like. I know that there are multiple standards out there for being able to estimate what embodied carbon looks like for different hardware. Dan, I know that the hardware area of the Green Software Foundation is always working on those sorts of standards as well to try and get an idea, especially in data centers, of what the carbon cost of computing looks like.
Yes, and I think they're always kind of like looking for use cases and scenarios where what has been defined by the Green Software Foundation can be improved and revised and iterated on. And so another initiative that they've done is workshops this year, and so trying to help companies try and put a lot of those principles into application. So yeah, don't hesitate to get in touch to try and get some of those quick start push to help you get started. That might include those numbers that you've just mentioned.
I want to take on one more question here. Pierre, I think this one is going to be for you. David Masselink asked about the discussion on the impact of an individual's load on the wider grid. Are there, and times or places, so let's include both, where a marginal carbon intensity signal could make sense for scheduling purposes?
So if we follow the research that has focused, I imagine, on using real world data to assess this, it's not really the case. I would guess that some very simple grids, where you only have a handful of generators, could provide a way to like construct a marginal signal that is credible. But as soon as you get to a large scale grid, the complexity of the grid itself is just so large that you could build any signal and call that a marginal signal, and no one would be able to verify how accurate that is. So that goes back to the credibility and verifiability concerns that I highlighted before. As soon as you're faced with like a real world large electricity grid, you're going to have a very hard time proving that the signal that you're using is actually predicting what it should predict.
Excellent. Thank you so much. Thank you to Pierre, Varun, and Dan, our presenters today. Thank you to all of you for attending. As we mentioned, we will follow up by email with the recording and with answers to the rest of your questions. We'll make sure that we've got other materials in there for you to refer back to. Any last words from anyone?
I was actually going to say one more thing. I think there's a famous thing. There's a common saying we say about what you can't measure, you can't improve. So it's very important to try and get those metrics. To start somewhere and to try and find the impact. I think one of the big things about carbon awareness and being able to measure our intensity at a kind of like sub-day level can already just make an impact by itself, and then be even more encouraging that actually you can see the difference and that you want to do more. by default. I ran an experiment a while ago for a previous webinar we did with the GSF, and I remember thinking if I was able to actually look at the difference between using daily averages against 30 minutes ratings, I was able to see a 20% reduction. Now, obviously, it was a specific scenario, and I think in that scenario, I was using workloads that were running at what I expected to be greener workload times. But I think it's important to know that potentially without that much effort, you could already make a difference, and that could help you on your journey. And this is, helped by data such as the one available from Electricity Map. And the other thing, because I saw a question in the chat, is being able to use spare capacity from data centers and providers. I think in some cases there's spot instances. I don't remember the name for each one of the providers, but the idea to use capacity that's not necessarily being used, and that also can help you improve very quickly not only your energy consumption, but not only your carbon rating, but also your costs, and have almost an immediate impact on your carbon emissions. And the final thing is that obviously, carbon emissions is not the only thing. There's more, but we don't want to overload you here. So, start, I'm going to say small, with your low-hanging fruit, and let's start together, make a big impact for the planet.
Thank you, Dan. Thank you again to everyone for joining, and we look forward to seeing you again soon.
Bye, everyone.
See you.
Thanks for hosting, Ryan.
Thanks, everyone.